So, welcome, guys. Good morning, all of you. We have with us Uttaran, and I'm pretty excited to have him here. So, the reason why I'm excited because he's very passionate about probability and statistics, and that really inspires me as a student and a teacher both. And he has been a teacher, and he has been instrumental in growth of Chinta. So, therefore, it's really great to have him here. And So today the topic has been suggested by him, and he has always been very different in thinking because he just tried to do something different other than the normal way of preparation and stuff. So and Uttaran's goal as a teacher is to combine the preparation of uh, the all the entrances and the honors together. So, and that is also something really interesting. So, we're gonna have a really great discussion today with him about all this, how to about statistics, his journey, and even though I'm sure that he will really put up a great show with a bit of his network issue at ISI Delhi. So, Uttaran, welcome Uttaran to the show, and I'm
Thank you.
really excited to have you here. So, so tell me, like, my first
I'm
question actually
I'm
should be
also
like, yeah, yeah, please go ahead,
yeah,
Uttaran.
I'm also really happy to be here because a vital part of my teaching developed in Chinta, uh, and I was in Chinta when I really had no kind of recognition on paper. So yeah, Chinta was a very important part of my life, and I still know Chinta. But yeah, I have trained myself from the convent in so yeah, but I'm still a well wisher of Tinka, so I'm happy to be here. And and yeah, I the why my experience is very interesting and different from others is because I have failed too many times. So that's why when Srijit asked me to give discuss my experience, I told okay, I would be discussing, but I will not discuss only on the perspective of competitive exams because I don't think that for example a few days ago actually Srijit only connected me with Jyotish Koda. I was discussing with Jyotish Koda that how you kind of prepare for B-Stat. He is a B-Stat MStat, and he is obviously Srijit knows that he is actually currently a professor. I was asking that how you actually prepared in your time. He was a pass out of 2003. I think he is a B-Stat batch of 2003, so it's quite a long back. And he actually told me that yeah, after our time actually we started teaching actually for B-Stat and MStat. So he was saying that yeah, you are right because we were just learning things and how much we could have done in our normal knowledge, school level knowledge. That was our that was our limit. So in that day, in those days, the exams. It's not that the exams were easy. You can see the tomatoes and all these things. They were pretty difficult. But he told me a very good point that those days, uh, among 30 problems, we used to do 10 problems or 15 problems. But nowadays, since it is the knowledge, the training is more exposed to the students, get exposed to this kind of trainings and all in there, which is good actually. The students attend 25, 26 problems amount out of 30. So the competition is growing. I'm not against competition, but I'm against the learning thing which is only based on competition. So I think Sri gets my point. Yeah, so that's why I told Sri that I would not only discuss my experience of failing in competitives, but my experience also on what I think that how we should learn in or how we should spend our 3 years in B.Sc because I actually wasted my B.Sc entirely in Narendrapur. I failed to get any kind of guidance, take any kind of guidance. We had a quite a very good teachers in Narendrapur, but I really failed to take their guidance because partly because I don't used to like statistics as much as I like mathematics. But later I realized I really wasted, and then I used my drop year quite well. But then again, COVID came, and things were pretty difficult, and it was very difficult to get on again on the continuity track when the COVID was there. So I was always been saying that if ISI does not take all the 3 rounds, that is PSA, PSB, and interview, it's pretty difficult for me to clear any kind of competitive exams, because I know I am not at all a competitive mentality person, and it turned out right. So yeah, so that was a very important experience for me, and I would like to share that. You can
Yeah,
ask
I mean
me what
this.
you want.
Yeah, yeah. So in fact, the reason I am also like this warrior mentality of Uttaran really inspires me, because uh, he has kept to it and kept to it and like has stuck to it, and he did it finally. And I really love this mentality of of Uttaran. So so
Many people told me that, but I think I could have not done this without my love for mathematics. But I love
of
mathematics
course, of course, of course,
insanely,
that
so
that passion is
that
important.
that
Okay.
kept me. Yeah, that kept me. Yeah,
Yeah, I mean, love takes people a lot further than
yeah,
we
yeah.
can. Coming back, like Uttaran, can you tell us about a bit about your the whole your growing up with mathematics, and I know how
I
you
was
love to teach
I
mathematics
was
and music
actually
together. So can you just tell a
I
bit about
was
your
yeah
journey?
I was actually very bad at mathematics in my school, my secondary school. I used to fear mathematics. I can tell you, changed my school in class 9, and when I came to the new school, where I actually gave the boards exams, and in that school, the mathematics question used to be pretty difficult compared to other ICSE board schools, because in ICSE board schools, the standard of mathematics is not quite high. Okay, I think so. I always prefer West Bengal board or CBSE board for better mathematics training. Though I think that in school, because that's the point of chinta in over that, it's to spread mathematics beyond the syllabus of school, and which I like actually. So so the so I was very bad at maths when I came to when in class 9, when I changed school and came to the school. Well, the first term marks I got in mathematics was 17 out of 100, and then the second term marks which I got is 25. And then I actually always desired to be a teacher, definitely, because my mother is a teacher and she inspires me a lot. But then also I got quite a very inspiring teachers even now also. So, and thanks to Srijit for connecting me to Jyotisha. He really supports and inspires me a lot. But I am lucky about teachers. I got really good teachers in my life, so, or else I would have been nowhere. Even one of them is Oshanida also. I He really inspires me to be here. So there was then I was think I wanted to be a physics. I want to study physics. So in before the final term of class 10, it was like if I don't pass mathematics, I would be not selected to the next round. So I worked hard and scored 75. And then I thought, no, this will not work. I need to kind of improve my mathematical skills to carry on with physics, because I used to love physics in that time. But then I went to a teacher. Actually, I don't know how he actually inspired me. The first day I went to his class, he told my mother that actually Uttaran can do maths, but he don't. So that kind of moved me somehow. I don't know, but the change was very severe, because after that I never kind of came second high in my entire school and in boards also. So that was something. In other subjects I was not great, but maths, there was I was kind of uh, doing well. But again with lack of exposure and all these things, because I belong from a very humble background. So there was this lack of exposure. For example, I never heard of KVPY or Inspire or RMO till I have joined college. So when I heard about RMO, I was going to RSM, and I was in class 12, so there was no kind of chance for me to. But RSM was a very important turning point in my life. I'm not talking about RSM by name, but the idea of RSM, because Chinta is also propagating exactly that, or I would say in a better way, because uh, the exposure of mathematics that I got there, like it was not about cracking BStat, because I knew that BStat is not my area. I can't crack BStat only by learning mathematics of that Olympiad mathematics of physics. That was not done. I knew that it BStat is a quite, and I still believe that to crack BStat you need a different kind of mentality all over, right? I think the people who actually crack B stats are really, they have a different perspective of maths from class 9, 10 itself. That is my belief. uh, but the exposure of mathematics which I got, for example, I started learning number theory, which I really loved that time, the elementary number theory book of Barton, and then the real analysis, Bartlett Sherbert. So these two books were very much into my life. It's still important now, because that was the time when I decided, no, there could be nothing other than mathematics in my life. So that was the time I actually started, and really I never appeared any kind of a joint examination, that, for example, engineering examinations and all these things. I my focus was always on mathematics, but somehow, yeah, in the middle of the mix, uh, my teachers and all, those suggested you go to statistics, there is more opportunity, and got statistics in economics and all this. So yeah, so other than ISI obviously, but but I went to Narendrapur, and there started a very mixed journey, because I did not used to like statistics. My focus was always on the mathematics. I can tell it very candidly. My roommate was a mathematics student, and I used to see, and he was a really great person. He was a really brilliant boy. Shanton, he is in Oklahoma now doing PhD, and yeah, uh, he used to learn algebra and all these things, and I used to think I should have learned. I go went to that thing also, why I took statistics. So 3 years of my BSc, almost 3 years, went in depression. That why I don't take mathematics, why I took statistics. But on the third year of the BSc, I had a really great friend, Sujit knows, Soham. We were kind of best friends from college, and he's also a great guy, and I did not say anything about him. But he actually inspired me then again, that why you are doing like this, you kind of quite uh, eligible. Then I thought of giving drop, and then also there was this third year project which I did. um, and that project was very interesting in a sort of sense, because I actually used nothing but classical probability, just a simple earn model. For example, my project was to measure accuracy of umpiring DRS umpiring decision in DRS system. So I mapped the entire DRS system to a earn model. For example, say the umpire, I want to calculate the probability of the decision of out stands after reference, given the out was given on field. That is, the on field umpire gave out, and it was referred to the umpire, he also gave out, or the on field umpire gave not out, and it was referred to the third umpire, and it was still not out. So I wanted to calculate these two probabilities and compare them out of this. So so the thing which I did is that I modeled it into an earn model. That is, I said that I uh, put it in a setup like there is an urn in which you have two balls, that is a red ball and a green ball. So one ball is uh, drawn out randomly, so you draw, say, suppose red. So red means the on field umpire gave out. Okay, so given it is red, so now if the decision is referred, you draw a set of balls from another urn which has a different configuration of balls, the composition of balls. For example, in DRS system, they, I think they see three things in their projection thing, that is the impact on line, pitching in line, impact on line, and hitting wickets, right? And there each of these three categories had three kind of categories itself, that is outside, the marginal case, which they used to call the umpire's call, that is whatever the umpire says they used to support that. So I took it as yellow. So they would not actually give any kind of weightage on our decision. They are just simple balls. They will not never affect our decision. But there is this red ball which satisfies the condition, and there is this green ball which does not satisfy this condition. Okay, so like you can say that green is -1, red is +1, and yellow is 0. So if the first turn gives you a red, and you draw three balls out of the second turn, and you get at least one green, that is at least one criteria is not satisfied. So what you do is that you drop the red ball that you have already drawn from the first turn, and you take the green ball that is not out. The decision is overturned. Okay, so I actually use that. That's it. You can understand this is a hypergeometric model. So actually, professors kind of appreciated this thing, and I also like, because at that time I never knew, I knew nothing about other than classical probability. The very few of statistics, and I actually managed to do something using just classical probability. So that was a point I actually understand and realize the beauty of statistics also. And then I thought of giving a drop, because I was not in a mood that I knew I had a gap in statistics, so there was no point in going. Maybe that year I could have got Calcutta University, which is quite good, but there was no point in going on with that kind of gap in my knowledge. So that's why I dropped. And then this COVID came, and it was horrible. 2 years, it was horrible. And I am really lucky to have some friends. Obviously, family people will always be there, but I really had some friends, and Srijit is one of them, obviously. So, so I'm really grateful to you people. But the thing which I would discuss today, I would like to discuss today is I would like three things to tell, especially to the first year students who will see, or the second year students, that which topics we need to learn quite in depth in BS, which I think, like for example, in BSc, first the thing I used to show this to the first year students. It's like a imaginary uh, hierarchy structure, you can say that. That the applied topics, that like um, for example analysis of variance, time series, yeah, these sort of things, quality control, or these sort of applied things. If anyone kind of don't like to read just for passing exam, that is fine, because this part will be again taught in masters, you know that. At this you can read in masters, and quite in details. It will be no pre-assumed knowledge will be assumed. Pre knowledge will be assumed when they will teach you in masters, or these topics like analysis of variance, analysis of covariance, and these topics. But the topics whose knowledge will be assumed that you know from BSc is the real analysis, probability theory, linear algebra, and statistical inference. These four topics are very important, and fortunately they are quite the important topics for the competitives also. So so I would always I always say students that don't neglect these four topics. For example, I can just tell you that in our coursework have been given in probability. The Antar Bandyopadhyay is taking our course, and he actually put the prerequisite in prerequisite of the course as the level of real analysis to the level of Walter Rudin, and the linear algebra to the level of R. Helmholtz. Okay, so now you know that Walter Rudin is a really very good book and quite a advanced book with respect to the BSc level. Many of the BSc students never touch the books. So that's what I'm saying. In the knowledge of real analysis, linear algebra, probability theory, and statistical inference is very important. And I would like to say how I actually studied those topics, the orderings, because I believe that notes, materials are not nearly enough, and solving just problems are not. Uh, uh, I think we should learn a lot of books. We should study a lot of books, multiple books, not thoroughly. Like I never studied Rudin thoroughly. I never studied Eridanus book thoroughly. But for example, I will just start with that. I think it's better. I am studying books, but if anyone wants to read real analysis, then that way of of mathematical analysis apostolic. Okay, that is a easier version of the Rudin's mathematical analysis. This is book in apostolic book. So I would
Uttaran,
suggest that if anyone has, hello, can you hear me?
yeah. So yeah, now it's better because it stopped for some
Yeah,
time. Yeah, I mean, can you start with that point? Like, you were telling about mathematical the
yeah,
analysis
analysis.
by
Yeah,
Apostol, right?
yeah.
Instead of Walter Rudin. So can you just not Walter Rudin? I mean,
And
yeah, Walter Rudin.
not
Yes.
not not instead, yeah, I told that if anyone finds Walter Rudin difficult, because many find Walter Rudin difficult, I find it's my favorite book by now. But many find that there is no question in denying that it's really a difficult book. And I started reading Walter Rudin after BSc, so I can understand people during BSc may find difficult. So I would suggest that, but feeling difficult means it does not mean that you will neglect the topics, right? So I would say that one can start with the mathematical analysis of Apostol. Okay, not the calculus books, the mathematical analysis of Apostol. Okay, so that book is really good book, and that is a easier version of the book of Walter Rudin. Okay, so one can start with that. But recently, I have, if one wants to give some time to real analysis and really want to learn real analysis, like really want to love real analysis, is then I would say recently I am reading in the book of Terry Tao, and it is very good. The analysis volume one of Terence Tao. It's a wonderful book because it has a lot of examples, and it has started from a very basic, very elementary background, like for 1 plus 1 equal to 2 and all these things. So it's wonderful book. And if
It started from piano's axiom, right?
yeah, exactly. And the beauty of the book, which I feel the beauty of the book is which I always try when I want to I want to introduce any topic to in a class, that I myself feel the need also. That's why I like the book so much. That is, like for example, I come to a class, I start a theorem. Okay, this is the definition, this is the theorem. This I find this quite I could not connect this. That is why I will be reading this. What's the point? My few of my students criticize me because I teach real analysis and linear algebra in quite depth, and they say that what's the point, and they're right. That is what the point in statistics, because we are not reading pure maths. So what's the point of studying real analysis, studying linear algebra in statistics? Now, the point is very simple, but it's for us to understand. Okay, so that is what the motivation. That is where the motivation lies. Is that is it is up to our it is up to us, to the teachers or our teachers, to explain the motivation. For example, you are teaching, say, you are teaching, say, matrix spaces, or suppose any B.Sc topic, let us say you are teaching continuity. Okay, so first of all, we need to express that what is the motivation why we are actually thinking of such a thing, right? So the beauty of Terence Tau's book is that he actually uses examples to show the motivation. That is very good. I like that very much. So I would suggest that mm, anyone who would like to study real analysis from a very basic point of view, very from a very basic elementary background, they can try the Terence Tau's book. But again, I am saying not one book, because that does not um, generalizes a perspective, but at least try more than one book. That is, if you can study the Terence Tau's book, could be your master book. That is, it's the main book which you are following, and it's the same topic you are seeing a bit from the apostle or Rudin or something like that, and you make a good note of yours, not the note a teacher is giving you and all these things. And don't neglect the proofs. That is very important, because all the problems which are given in the problem sets or exams or wherever it is, wherever you are applying any theorem, those problem is nothing but a particular case of that theorem itself. So a theorem is a general problem, and the proof is a generalized solution to the problem. So don't neglect the solution. Okay, so so see the proofs, understand the proofs. What I do is that i I myself write proofs in a very short, I like writing short proofs. I find it very useful actually. It actually sharpens my thinking skill. It develops my problem solving abilities also. That is, when I see a proof, say one page proof, and I need to fit it in my note, which I do for myself. I never tweet my note to my students. So when I do it for myself, maybe I never read that note in future also, but I still do. I have a habit of writing and reading. So reading and writing. So when I write the one page proof in 2 or 3 lines, so you can understand that I actually make the precise thing of the note. So sometimes I actually do my own proofs, right? So that actually helps me to think. That is a very important practice. It's uh, it's it's it, it will not come very easily, because for me also it never come very easily. It took time, because it's not that I sat with pen and paper on the first day and I tried it, and I started writing short proofs. It's not like that, but it will take time. But that is the point, right? You need to give time. Last yesterday only, a student of mine was telling me that, Dada, I do all of your classes, but I couldn't solve these kind of problems myself. So I asked him that, how many time do you spend on these problems when you get stuck with a problem? How many time on an average you spend with that problem? So he said 30 to 40 minutes. Now I said that even we now also spend our entire day if we can't solve a problem. And it is true, oh, if we can't solve a problem, basic problem, BSc level problem, these days also we spend thinking all day. If someone kind of says something to me and says repeatedly, I get infuriated because I'm thinking the problem. So I think it happens to many of us now also. So we spend days and weeks for a problem, and there 30-40 minutes is nothing. Because when one solves a problem, when one takes a day to solve a problem, he actually learns the amount of knowledge he is spending for that problem, and that is huge. With that knowledge he can solve 10 or 20 more problems like that. So this is what I have experienced. So it's very important to spend time. You don't understand what you are reading, you keep on reading, keep on reading until an analysis is absolutely clear to you. So that is the way of learning. You need to give time. When you are learning, you should not keep in mind that this is in jam, this is in ISI, this is in something else. No, you are learning for yourself. You are learning for your own growth. The jam ISI things will start, definitely start from 2 or 3 months before the exam, not from 2 or 3 years, because these 2 or 3 years is for your own growth. And if your own growth is complete, then the jam and ISI is just a matter of fact. So a matter of time. So that is my belief, that when you are reading a topic, don't keep in mind that whether this is coming in jam, this is coming in semester, this is coming. No, just you like it, read it. If you don't like it, try to get the motivation, because it is important. The I don't used to like applied maths, applied stats, but I have to go on with it, right? Because I am a statistics major, my field is statistics, so I will have to go on with applied statistics. So what I do is I just try to convince myself that this is important. This is something which is important. We can't survive without solving these real life problems, and applies that actually help us in solving real life problems. And there are also elements of beauty in applied stats. So see to that elements of beauty that will motivate you to read that. So if you don't like real analysis, then study real analysis with probability, because probability is something which you need in statistics. And in probability you will actually see the application of real analysis at every step. For example, you are studying a CDF, there is this concept of right continuity, and there is this non-decreasing thing, and all these things. There is this concept of derivative when you are going towards the PDF. So, for example, I was teaching the PDF and CDF things before my ISI exam actually. And I actually the, people actually think that PDF and PMF are same thing, though they are analogous thing. They are not same actually. So I told that. So one of them asked me what is exactly a probability density function. So I just obeyed the definition which I learned in calculus. That is, if CDF is a probability measure, that is, if CDF is a probability, if CDF gives us a probability, then when you are differentiating it, you are getting this PDF, right? So if CDF is a probability and we are differentiating and getting the density function, the density function is nothing but the rate of change of probability. That is as simple as that. So that is a density function. So just use your common sense, use your mathematical sense. That's a reason why real analysis is taught. Real analysis is not just a course. Real analysis is very, very important for probability part. But so I would always tell people, don't neglect real analysis. It's a very important part. But it may not attract you, but see to the motivations and at least go on with it. And same thing with linear algebra also. For example, you have learned mapping, right? In our 11 12 classes we learned mapping. That is, we have a set A, we have a set B, we map from A to B, each element of A to each element of B. So now we can actually have a geometric interpretation of the mapping also, x axis, y axis, and so on. But what if we extend our dimensions? What if we extend our variables? That's when the real need of linear algebra comes. Because what is a matrix at all? What is a matrix? Matrix is just not an array. It's an address where a vector is mapped under a mapping from a vector space to a vector space. So that's the importance. So linear algebra is nothing but you are working with more variables. So so that is what, uh, try to understand the motivation. So that's the importance of linear algebra. Because in applied statistics also, we learn, we work with a lot of variables. Like it in stats, we have multiple variables, multiple parameters which we want to estimate. And there we need to have something, in some tools which can handle this sort of multidimensional structures. So so the, so again, there is a reason not to neglect linear algebra. And linear algebra, I will just tell you that I actually gave my student a very exact my plan or my strategy to how to deal with linear algebra. So I'm just telling you the set of books which I kind of suggested. So Srijit, would you like to just put it on the chat, the books, list of books? Your mic is off actually. Your mic is off.
Yeah, do you have a text format?
Yeah,
Then
yeah,
I can send it.
yeah. I'm just
You can
sending
send
it
me
here.
over to WhatsApp. I can copy
Yeah,
and paste
in
everything.
WhatsApp. Yeah, sure. But I think it is. Yeah, yeah. I said so. The books I recommended is Linear Algebra by Friedberg, Spence. I have I sent the text. It's Linear Algebra, Friedberg, Spence. It's a very nice book. The discussions are very good. So one can start with that book. Then Linear Algebra by Gilbert, Strang. And but I would suggest that um, if you want, you may skip reading this book, but you definitely go through the video lectures of Gilbert Strand in YouTube. It's really good. And the most important thing, which is very important in these kind of things, in this kind of abstract mathematics, is that to get a geometric idea, it's a get a geometric viewpoint of that thing. Because I believe that getting visualizing one thing, it makes more real to us, as that's a human psychology maybe. But I think Gilbert Strang actually teaches it from a very geometric perspective, so it will help. So definitely, I would suggest go through the 35, 36 lectures of the Gilbert Strang, and then there is a this book is really good for statistics people. I did a lot of problems this book before ISI. It really helps. That is Linear Algebra and Linear Models, RB Bapat. So Bapat is actually our faculty. as well. So this book is really good. This book is really for a statistician. So I would say that use it as a handbook, okay? Because the linear algebra part is precise, not in that much of depth, but the problems is really good. And once you know the topic, the theory part is good in this book, but not for a first reading. I would discourage reading this first. Then this book is very good again. Linear Algebra, Rao Bhimasankaran, and difficult book in popular views, but nice book. More from a mathematical perspective, good book. And then the linear algebra from Hoffman, Kunz also. It's from a mathematical perspective, but if you want, not necessary. But the way you can start reading, I would say that start with a very elementary definition of group, rings, fields. That is very basic group theory. The and basic entities of abstract algebra, like what is a modular class, whether a modular class makes a group or something like that. So these kind of things actually make you habituated with what is a group, what is a ring, what is a field. So it's important to understand the structure of the vector space. So a very basic and elementary introduction to group theory, and then you move on to the Gilbert Strang lectures or books that would give you a very lucid visual perception of the elementary concepts like vector spaces, dimensions, linear transformations, matrices, etc. Then move on to Friedberg Spence book of the linear for the linear independence parts. It's very good there. Especially go through the proofs of those theorems. The proofs are really easily written, so it's very interesting book. They are quite precise and elegant, and the discussions are good. And then slowly and simultaneously, you can move on to the book of Rao Bhimasankaran and keep reading this with R.B. Bapat book. As I said, it's not for first reading, but once you have got an introduction to the topics, you can start reading Rao Bhimasankaran and R.B. Bapat. Then you will also get a perspective of not only how to think for the problems, but also why this course is important. One for the statistics measures. And obviously, I gave I gave a warning after this that following this and doing regular problems should serve more than the purpose. Going through each and every proofs of the theorem are highly recommended, as the proofs will guide you to the solutions of the problems, which are nothing but some special cases of the theorems or the union of some theorems. That is, maybe in a problem, for let's say in a problem you are using in say k theorems, so t1, t2, tk are these k theorems you are using in this problem. So basically this problem is nothing but some special case of this union of t1, t2, tk, right? So the proofs of t1, t2, tk may help. Like for example, who have done my classes or who have seen my solutions, you can see that I hardly use theorems in my solutions. It's not that I don't remember theorem, but I don't use theorems. What I do is I put the statements directly and give a short logic into my solution itself. So it becomes a part of the solution, and it also becomes very readable to any layman who are not maybe not aware of that particular theorem. And I can tell you that uh, this thing is very much appreciated in ISI. Because why I'm telling this, I have experienced this, that this year also quite has quite out of many, quite a few calculation mistakes in my PhD sections also. So but the reason I wrote the solutions very
Uttaran,
early,
your net is. Can you just
I
wait for 1 minute? 1 minute. It seems like he has lost his internet connect. Oh, he's here.
it's okay.
Yeah, it's fine now. Yeah, great.
Yeah.
So you were telling that this is very appreciated in ISI,
Yeah, yeah,
and that writing of proofs. Can you just
yeah,
move ahead from
yeah.
there?
Because this year also I made a two or three calculation mistakes in my PhD part. Okay. And I was thinking that, and I made those kind of calculation mistakes which actually made my final answer wrong. Okay. This kind of calculation mistakes I made this year. But mm, according to my rank, I can say that those mistakes were entirely overlooked because I wrote a very detailed solution, and I never used any theorems. I never used any theorems or kind of any. I gave a detailed proof of everything. So presentation of the solution is very important. and ISI especially, it's very important. I even last year also, last year, I was in the second place in the waiting list. I ended up in the second place in the waiting list last year. Last year also my PSB exam was very bad. You know that my
Yeah.
PSB, generally my PSB is the strongest part, but it's one of my strength, but it was very bad last year. I panicked a lot. I panicked a lot because of that linear algebra problem. I got stuck in that linear algebra problem. I panicked a lot, and I actually scratched off solutions which I wrote correctly. Okay, so I wrote a solution and I scratched it off. Okay, so last year I wouldn't have been on the waiting list if they had checked that solution also. Okay, so if you write a solution properly, they check it. That's a very nice thing about us. So they check
Yeah.
the problem, they check the solutions. So the presentation is very important in us, and how you are presenting. If you write just the theorem, they will give marks, definitely they will give marks, but they appreciate if you kind of, this better than me actually, that if they appreciate more if they if you give a sort of short proofs or short explanation of the theorem itself that you are using,
Yeah, of
or
course,
why you are
because
using. Yeah, that is
yeah, I
that
mean,
is very important.
yeah,
So
yeah.
that is more or less the linear algebra thing which I wanted to share. And lastly, I would like to share the probability thing. So the probability thing, a good book obviously for the first reading of BSc is Blitzstein. I always suggest that book. But that book is a very informal book. Okay, in linear algebra, another book for Bengali students is that of Arnab Chakraborty. That is a very nice
Very
book.
good book.
Yeah, that is quite informal, but an informal understanding is important. On the same parallel to the rigorous understanding. So the rigorous understanding and an informal understanding both are important. So for that informal understanding, I would say the Bengali students can use the book of Arnab Chakraborty, linear algebra. Then
Yes.
again in the probability, Blitzstein Wang book is again a very informal book in a sort of sense, because it lacks rigorous theorems and rigorous proofs and all these things. But what the book actually abundance with is problems. The problems are really good, and it would actually motivate you to learn the topics. That's the good point of the book. I would say go through the Blitzstein lectures in YouTube and do problems from that book. But again, I would say there are some topics in that book which are actually core statistics topics, which he gave as an example or as an application of that. So that is also a very good thing for knowledge. So I would say people to follow both the lectures and the books and the problems. And then one can, for the random variable part, one can go through one can go through the Rohadgi Saleh book, for the random
So the
variable part.
issue is that you told Uttaran, I have seen with the students actually that since they have not developed the reliances so well that they get stuck at the initial that sigma measure and all those sigmas algebra thing that is introduced in Rohat Gisale. So that point they get stuck. So I think real analysis, as Uttaran has told, really if you're really good, then that part really. I mean, not really real analysis, but it's all
Exactly, they
about.
have
It was mainly set theory. So
set theory. Yeah, so that's a you made a good point here. I would like to come to this point. That is, this year ISI PSB first problem, the first problem of this year. Yeah, so this year
it's
they actually
beautiful
gave a problem. Yeah, it's a very simple
from
but
real
beautiful
analysis.
problem. Yeah, and they actually gave a problem from real analysis this year, because they generally give problems from calculus. They give either continuity or differentiability or something like that. But this year actually they gave problems from real analysis, and many people didn't do it. many people didn't skip that problem because that was a problem from real numbers. It was simple case of Archimedean property. So you just need to assume that there is a supremum of nk, and then you just need to show that your assumption is wrong. So there couldn't be any supremum. So it's very simple Archimedean property. It's a case of Archimedean property. So the reason students skip that problem is because they are never taught real numbers or real sets or basic set theory. What the point, the chapter from where they start real analysis is sequence. But sequence is quite an advanced chapter. Before sequence, you need to learn set, intervals, and these sort of things, and properties of real numbers. There are very basic properties of real numbers, so you need to learn those properties also. So that is very important. Yeah, that is very important, basic set theory. The and yes, in that sigma algebra and those kind of things, you can do it both ways. That is, set theory is important, and another way is trying to use motivation again. That is, what is the motivation of sigma algebra? So when you are um, presently I teach this probability from a, say, theoretic point of view. First, when I used to teach in Chinta, I used to teach probability from a classical point of view, which we saw, which we learned actually. But presently I teach probability from a set theoretic point of view. I actually do the classical probabilities more through problems, and then move on to the axiomatic probability and start from the set function. So here it is very important to understand probability as a set function. So when I'm saying as a set function, we are taking, say, the sets as our argument, right? So what is the domain then of that function? That domain is that sigma field, the collection of those sets. Like, for example, if we are given a point function, for example, fx equal to y, so x is here the argument, and set of all x that is mapping to this set of the y's are the domain, right? So the set of all sets that are mapping to 0 1 is the sigma algebra. And obviously now you can just use your motivation for the sets, that you are finding the probability of events. So these sets are nothing but events. So the sigma algebra is nothing but a collection of events, collection of event space. And there is very nice properties. For example, you can take power sets of, if you are trying to take, if your sample space is countable, even if it's infinite, if it's countable, then you can take the power set as the sigma algebra. Then that is the collection of all possible subsets of your sample space, and there is no problem. You can define a probability measure, or you can define probability there. But actually, if you do otherwise, that is, if you kind of, if your sample space is uncountable, say for example your sample space is open interval 0 to 1, or a closed interval 0 to 1, this is your sample space, that is, you are picking a real number randomly from 0 to 1. Then if you take the power set, you can't define probability at all. So that gives us a motivation of Borel sigma field. That is why we need to actually construct Borel sigma field and define probability on that domain of Borel sigma field, taking the Borel sigma field as the domain of our probability set function, because the power set does not works in the uncountable sets, because there is this kind of sets which we can construct, which we call the Vitali sets, which actually which actually contradicts the third axiom of probability, that the axiom of countable additivity. Actually, this happens for any kind of measures, but for B.Sc it's fine with probability. So yeah, it's very important, it's very interesting actually, if people study that way. But even if people don't like that way also, but I would say that Rohatgi Saleh's book is good for the random variable part, And one can also see the outline book also. The outline book is also good for random variable part. Then there is this Mood Gravel book. Mood Gravel book, I would suggest Mood Gravel book for the understanding of moments and variance and what this sort of measures of central tendency exactly tries to represent. There is a very good discussion on that, on those topics. And for sampling distributions and transformations, you need to do a lot of problems. That's it. You need to do a lot of problems, and in these circumstances, understanding of Jacobian is very important. What how you change the variables, and how Jacobians come into play, that is very important here. Or
So that
it's a
therefore,
very
I mean that
complicated, though.
Jacobian part, the multivariate reanalysis comes into the play, like
Yeah,
geometry of
yeah,
that. So
yeah,
that
exactly.
is
That is very important, because sometimes people make, kind of say it's given for transformations like x equal to x square, yeah, y equal to x square, and they just use the Jacobian when, say, suppose x is real. X is any real random variable, and you are taking the transformation y equal to x square. In this case, you can't just go on using Jacobian. You need to first partition these things into two sets. That is, when x is less than 0 and when x is greater than 0, and then you must go on. Right. So these kind of things are quite important to understand, and to be very conscious with. Actually, you have to be very conscious at every step what you are doing, whether it makes sense or not. This is something which Blitzstein actually told in his first lecture, that at first you need to see whether the answers you are giving, they are they are making sense or not. For example, a very trivial example of this is, if you get probability greater than 0, then you are definitely wrong. And or a probability greater than 1, sorry, probability greater than 1, then you are definitely wrong. Or if you get variance less than 0, then definitely wrong. So these kind of things, which are basically trivially common, you have to be very careful about these things. This is very important. And for coming to the statistics part, that is the statistical inference part, I would suggest Castleberger is the best book. By far, there are quite a few books. Rohatgi also have a part of inference. Mudgravil also have a part of inference, but I always find Castleberger the best, because the discussions and the rigor, both in this book, is very nice. They have gave the motivation. Maybe it is a bit difficult on the first reading, but I would still suggest a first reading of this book only. Maybe first time one read and find it difficult, but again, as I told, don't let it go. Just stick with that for a day. Maybe you just read that page for all day. Then you will understand that when it will get clear, it's just a fraction of seconds. Okay, it will just get clear. That's the that's the beauty of understanding. Actually, you are not understanding whole day. You are thinking of it, and you are not able to understand that thing. And maybe a night when you sleep, when you're sleeping, maybe you're scrolling Facebook or something, you are just thinking, but in your mind the thing is going on, that what is this exactly thing. And then again, just a click happens, and you, everything is clear. And this is actually real, it happens to all of us. The understanding is just a fraction of seconds, but sticking to it is the thing. So that is very important. That is very important. I always say that preparation is not how you perform when things comes which you can already know how to deal with. Preparation is for the things how to deal with things which you have never dealt before. So that's what preparation is. Preparation is not for the things which you have already dealt before, because you know how to deal there already. Preparation is for the things which you haven't dealt. So I would say that even in point estimation, or even in testing of hypothesis, also set theory is important, very important. Set theory, because I only saw a 2020 problem of testing, that trimmed mean problem of PSB. I don't know if you remember or not, but that PSB problem of testing, ISI PSB problem of testing 2020, there was given a trimmed mean. That is they were taking m observations out of n observations, and they are making a set of trimmed mean. And
Yes,
that
yes,
problem,
yes.
was
You
nothing
told
to
me a
do.
solution using Bonferroni's
Yeah, yeah,
inequality.
yeah, exactly. That problem had nothing to do with testing at all. It's a problem of simple Bonferroni's inequality. So that is very important, and inequalities are also important. It's a very important thing, actually. Actually, Shoham can tell many things about inequality because he loves inequality. I'm not that good at inequality, but inequalities are there, are very important and very useful things. So yeah, that's all. I don't think I have anything else to say, but
So
I will
Uttaran,
say that three topics or two topics, I would say, read it in depth, as much as depth you can go. That is real analysis and probability. And if you want linear algebra, these three topics, go to the depth, as much as depth, especially for the people who want to be in academics after MS. Yeah. Yes.
so
Yes, please.
so we have few minutes left, and
Yeah, yeah, yeah.
Abhirup has a suggestion as a request. Abhirup Moitra, he's a great fan of yours. Uh,
Oh,
so
yes.
so
Yeah.
he wants like so he wants. I also loved it when I heard it from you. So he wants you to tell about the connection between sigma algebra and music theory, which I also telling in the beginning, like you connected music theory and sigma algebra. And if you can
Oh,
end the session on that note, yeah.
I, I gave it as an example. That is nothing theoretical. It's a very, it's a very kind of, you can say it as it's as a thought experiment, or as an example I use in class to make things interesting. But unfortunately, it does not works very well with everyone. But yeah, it's like in our I am I am a fan of classical Indian classical music. So in this Indian classical music, there is a very there is a very basic entity of Indian classical music, is that rag. Okay, what is a rag? So definitely rag is not a song, and rag is not a concerto also. So like in Western classical music, they write concerto, that is some paragraphs of music in musical notations, and they follow that and they play that. So like it is in that is the style of Western classical music. But in Indian classical music, it's a tradition of 1,000 years. Okay, and it is an undocumented knowledge. Basically, you go to a Indian classical teacher, a ustad or a pandit, they will never let you write anything, because what they have learned from their guru, that was absolutely orally. They learned everything from their gurus, and they will teach you that to orally. You will never be able to write anything. Not that anything, you will be, they will allow you write, but not many things, not especially not the compositions. So 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 nowadays people write, but in ancient days, basically, they used to, the thing was entirely from an traditional point of view. So what is a rag, first of all? So when I used to listen music, what I used to think to myself, that what is rag? I never had a kind of proper training in classical music, but in my house people have, and I want to have someday. But so I what I used to ask myself, that what is a rag? So then I used to kind of learn from my aunt, who have a kind of have a kind of training in Indian classical music. Have very elementary, and what she was saying actually about rag, or about the structure of rag, I find it very similar to that of the sigma algebra or collection of sets or collection of subsets. So I use that example. For example, in sigma algebra, what we do is that we have a sample space, and we make, as I told, we make the collections of subsets of sigma subsets of this sample space. That is, omega is our sample space, and we are kind of making different subsets of omega, but we are following some limitations, like closed in complementation, closed in intersection, and all these things. And the entire set would be a part of the sigma algebra. So what I found is that a rag is something like, you can play a rag for 50 minutes, you can play a rag for 5 minutes, and you can play a rag for a whole day. So a rag is nothing but permutation and combinations of uh, a subset of a subset of notes. For example, in our Indian scale, we have 13 notes, basically 7 prime notes, that is 7 basic notes, that is sa re ga ma pa dha ni. And some of these notes have minor and major, like this. And yeah, and some have kind of different variants, actually. For example, ray have two kinds of variants, that is common ray and shuddha ray, or that is major and minor, this kind of things. So they make 13, all total 13 notes. So when you construct a rag, it's like you choose 7 notes out of this 13 notes, so that they complete a octave. So what is an octave is that you start from a scale of nth level, that is sa re ga ma pa dha ni, and you end with the sa of the n plus 1th level, that is sa re ga ma pa dha ni sa. So this sa is a sa of the n plus 1th level, if I have started from the nth level. So this is a just scale. Okay, so this is an octave. If, so you make an octave out of here, and now this octave is your sample space, and you kind of make compositions based on these octaves. And obviously there is this different time, you divide the time with respect to respect to percussive beats. Like for example, you can use, if you use 16 beats, that is called the teen tal. So it's 1 2 3 4, 1 2 3 4, 1 2 3 4, 1 2 3 4. This these 16 bits. So you are dividing a time frame into 16 bits, and then you are dividing it for partitions. So for example, if we take the simple basic rag, that is Bhairav rag. So Bhairav rag, the octave is Saregama Padhani, but here Re and Dha is of minor scale. So it's Saregama Padhani. So like this. So if you there is a composition on Bhairav, is that you use this thing, that dha pa dha ma pa dha pa dha pa ma ga ma re sa re ga ma pa dha ni sa re ni dha pa ma ga ma re sa dha pa. So this is going on 16 beats. So 1 2 3 4, and like this 1 2 3 4 again. And this is just, there is no notes outside of these 7 notes, actually. And it's just simple permutation and combination. So the next line comes, ni- I don't actually remember the composition now. So this is just nothing but permutation and combination. So I used this example as as rag. So rag is nothing but a musical possibility, you can say. So you take a subset of some notes which make an octave, and then you obviously following some restrictions that depends on each rag, that you can't use this scale, you can't use that scale, you can't use this note of that major scale, or this note of minor scale, because that depends on the mood of the rag. Because rag is and a very important and a very nice thing about rag is meaning of the word rag is mean color. It means dye. Dye means D, not dying. It means color. The dye of color. DYEIT. So that is very fascinating because as music, you are naming musical entity as color, which you can see. So that gives something, that tells something about the people who actually made this kind of things. It's very nice. um, I think one can go and see some videos of Manjul Bhargav if one wants to understand the essence of mathematics in music, because Manjul Bhargav plays a wonderful tabla. He is a student of Zakir Hussain, so he
Yeah,
actually knows music and mathematics wonderfully. I actually he started getting this exposure from his lectures. Then I saw this, and this is an example I use, yeah, in class. But just to make this is not a official thing. This is not a formal thing, but it's something which I just use informally to explain. That's all.
that's really
That's
beautiful. Like, I really find it fascinating because I heard it and I saw your lecture that, yeah,
yeah,
it was
I
great.
tell that I myself find it very fascinating. So as a rag is nothing but a musical possibility, basically, because all of this set of compositions make the rag itself. So it's like the sigma field, more or less. Yeah, more, not
Yeah,
even sigma field, it's a collection of sets actually, yeah, under some
super.
restrictions. Thank you.
Thank you so much,
Yeah,
Uttaran.
yeah,
Like, I
it
wish
was.
to continue speaking to you, but I have another.
No,
Uh,
it's fine.
uh,
And
I
yeah,
would
and
love
I
to
also will have to go to lunch and all these things. We will definitely again meet some.
catch up with some interesting
Yeah,
discussions like this.
interesting
So
topics.
yeah, I
Yeah,
mean,
more,
Uttaran loves probability a
more
lot, so I'm
theoretical.
sure he will. Yeah,
Yeah, more theoretical things maybe next
of
time.
course, of course.
Because today it was a very informal discussion. Next
Yeah,
day maybe
next time it will be
more
more, mathematics and
mathematical discussion. Yeah, yeah,
symbols.
yeah, more rigorous. Yeah,
Yeah,
thank you,
yeah.
yeah.
Thank you so much,
And
Uttaran, and thank you.
best of luck to everyone who is kind of want to get in this race. I'm telling you that this is a very difficult thing. Definitely, this competitive in India is a very difficult thing, because especially in statistics, because there the opportunities is really sparse. It's really sparse in India. Mane, this year I can tell you, I want to add actually that this year still now the other universities have not decided whether they will take exams or not. Like for example, a very good exam, from the examination point of view, who the exam of the entrance exam of HCU, Hyderabad Central University, used to be good. It's a good exam. The paper used to be good and all these things, but this year they are not taking exam individually. They are kind of doing this kind of CUET or something like that. The central one examination will be there, and from that, like for it's like almost like JE. Okay, so from that ranking they will be taking students. So this is very difficult. The things are really getting difficult. Yeah, after COVID, the situation of the masters. The reason why I'm telling this is I have seen students have neglected study very much in this COVID. They don't even give any importance to studying at all. Okay, so this is a very difficult time they are going through, and they are not understanding what they will be facing in coming days. So in India, the situation is very bad, because leaving IIT and ISI, there are 50 odd seats in IITs, and there is 30, not even 30, 28. 27 seats in ISI. So leaving these 78 or 77 seats in India, none of the seats are quite sure. Like sure in the sense that none of the universities have decided whether to take exam or not. For example, Calcutta University will not be taking exam, as I have been told. So they have stopped taking exam. They will be never take exam in future also, in entrance exam. As I told, HCU also dropped their examination, and they have actually collaborated with the CUE. DU yet to announce their examination date, which they would have announced in back in July. So July is gone. So they are yet to announce. Maybe I think they will not announce. They will also drop their examination, and they will also participate in CUE. So leaving this DU, HCU, and CU, the colleges which left are not that good. So I would always, and there is CMI also, but CMI is very costly for a bit a class of students, I would say, and the course of CMI is not also very much
It's
statistics
also
based.
applied.
It's a course of yeah, it's a computer science course. So so the situation is there. Situation is there. I you have to be very. I don't know what to tell actually. When there is 100 odd seat, not even 100, 70, 80 odd seat in an entire country for a subject. I don't know how can I tell students, because even the students give their best. It does not kind of there is no surety what they will end up doing. I mean, if you sample students from each college, each good colleges from West Bengal only, or yeah, I'm saying from West Bengal, you will get more than 80 students who are actually eligible, who are good students, students with potential will get such students. So how I don't know really. The competition is getting tougher and tougher every year, and and the people who are into this system, they are not at all understanding this. I think they should, this Calcutta University, HCU, the good places. These are good places for statistics. Actually, they teach good. They teach well. Their course is good. So they should take exams. They should take exams. They would bring some improvement in this competition, or else it's pretty difficult. It's pretty difficult, because I can tell you what is the situation of Calcutta University. The students from our college, for example, Narendrapur or Presidency or Xavier's, they score better than the CU people, Calcutta University people, or other university people, because they score better, because definitely our course structure is better than the other places, and the pressure of examinations that is there in Calcutta University, not the pressure on the difficulty level, but the administrative level. Like for example, CU students didn't knew whether they will be giving offline exam or online exam even before a month of their exam. So this was the situation. Just before 1 month, they got to know that there is some blame must go to the students, because students have neglected their studies. But I'm saying that they should have told, Calcutta University should have told earlier that okay, this semester you are doing offline classes, then the examinations will be in offline, right? They should have told this, but they never told. So this stress is a lot of stress. This stress, we don't have to handle this stress, or even our juniors from Narendrapur or Xavier's or Presidency don't handle this. So naturally, even their course is difficult, maybe the examinations are difficult, uh, they score better than this CU people. And what happens is that they take on marks these people who have from the people from our college or presidency or Xavier's who haven't got any of IIT or ISI, they get Calcutta University easily out of their marks due to their marks. So now it's not a thing that there is no good students outside these three colleges, right? So there are good students outside these three colleges, but what about them? They don't score well or not as well as these students in these colleges, because say average GPA in Narendrapur is like 9. This is the average GPA, right? In Narendrapur, it's 9, and same goes with Presi and Xavier's also. So kind of, so, and if you see good students in Calcutta University struggles to get 9, not because of the difficulty, I would say, but something to do with the administration. So if Calcutta University does not take exams, what happens is that these students get overlooked. So this is a problem. This is a problem, but it's very difficult problem. I don't really know what to tell students. I can just tell you people that go through your subjects, explore the subjects, and just try to finish this struggle as soon as possible. Because once you get placed somewhere better, then you are out of this hell actually.
Look,
Because this examination, this competitive, and the thing is, and the truth is that this never helps you. For example, the effort you are giving to get to IIT or ISI, after getting to these places, this preparation, this effort will never help you. That's the thing. So it's just part of the competition. It's nothing to do in our countries like ours. You have to do this. You have to deal with this. I'm not demotivating, but I'm saying just be very careful and be very much dedicated to what you want. That's Thank you.
thank you,
Thank you.
Uttaran,
It's really,
for everything. Yep.
yeah,
So I am sure things will get better and everything will be fine. And yeah, so I like this Uttaran statements, and I want to
yeah,
end with that. That yeah, please be passionate about your subject, whatever you're learning, and then only you can
yeah.
stick to it, to your dreams. Okay, thank you guys. I'm sorry I could have done it a bit longer, but I have to cut it short because of my
No, no,
other
no. It's
engagements.
fine.
So, thank you guys, and thank you, Uttaran. And I have to uh, say goodbye now to all
Yeah,
of you. Thank you for joining in, and yeah, bye bye
yeah.
now.
Goodbye.
All the best, Uttaran. Have a great lunch at ISI Delhi Mess. Bye. Bye,
Enjoy.
guys. Yeah.